Hi, I'm Matt. My claim to fame is writing JSSpeccy, the ZX Spectrum emulator for JavaScript. Now, at the heart of any emulator is an infinite loop that reads a byte from memory, decides how to interpret that byte as an instruction, and then moves on to the next one. And what this means for your code is that you have an enormous switch statement covering every possible byte value and what action it has to perform for that byte. And a lot of these actions are very similar, performing exactly the same operation with just one or two of the parameters changed. So writing this switch statement out by hand would be very tedious and error-prone. But luckily we have computers to do this sort of job. So instead, we can write a template function for each class of instructions and have that return the appropriate snippet of JavaScript as a string for each parameter that gets passed in. And using functions like this, we can build up this enormous switch statement as a string and then eval that to get back a function that we can use as the main loop of our emulator. Now, if we're doing this, you should definitely use CoffeeScript because it has multi-line strings and variable interpolation, which are ideal for this sort of templating construction. But let's take this further, because if we're running basically the same sequence of instructions over and over on the Spectrum side, it's a bit wasteful to be whizzing around this switch statement a million times a second to perform this decoding step. But if we've got these code snippets for each instruction as a string, there's nothing to stop us from putting those together in the order they appear in the Spectrum code, and then evaluating that so that we've effectively translated the Spectrum code to native code running on the PC. Now, in fact, this does turn out to be harder to do for a home computer like the Spectrum, where programs are loaded into RAM as opposed to a console where the code that you're running is burned onto a ROM chip, because you've got to watch out for when that code gets overwritten, and therefore you have to invalidate the compiled code that you already have. So things do get a bit tricky, and that's why I haven't actually done this yet, but I will. And you've got to realise that all of this is something that's pretty much unique to JavaScript, because for the first time ever we've got a platform where all of your users have a really good optimizing compiler available. And even better than that, there's an arms race between browser makers to make those compilers better and better, and eval is what gives you access to all of that power. Incidentally, there is a curious performance issue you should be aware of, because normally the code in the eval is evaluated within the scope of the enclosing code, and for some reason that's much slower than regular program code. However, if you use an expression that resolves to eval, like 1, eval, then this triggers a shortcut that breaks some of the scoping rules and makes it fast again. And for the gory details on that, Google for indirect eval. So it seems to be word of God that you should never use eval in your code. Well, maybe not word of God exactly, but Doug Crockford anyway. And certainly if you're using strings to hold bits of code to run later, then you're probably doing this wrong. But if you're genuinely building code dynamically on the fly, then eval can give you a whole new approach to problem solving that you wouldn't get in any other language.